All right. What's the formula that relates distance, rate, and time? Please raise your hand. Tylin. Distance equals rate times time. Got that one. Formula for the area of a rectangle. Area of a rectangle. Anybody? Justin?
Base times height.
Okay, so area would equal the base times the height. Area of a triangle. Sarah? That would be 1/2 the base times the height. So you have to make sure that the base and the height might not be a side on the triangle. That only happens if it's a right triangle. You've got to make sure that we call it an altitude is another word for it. And next one, let's see, Amelia, area of a circle. It is pi r squared. Sometimes people get confused with this one. Does anybody know how to well, first of all, what is this one? That's the circumference. They've all got both of these have a 2, a pi, and an r in them. Does anybody know how to keep straight which is which? What's that? You could flat know the difference. You could know which is which. Yeah. Very good. If you square something, it's two-dimensional. So the one with a square in it, area is two-dimensional. So that's got to be the one that has the square in it. Okay. Let's see. I think I know this one. Pythagorean theorem. A squared plus b squared equals c squared. A and b are both. They're what? They are pretty. I agree. Legs on a right triangle. They are the legs of a right triangle. C is the hypotenuse of a right triangle. What is the standard form for the equation of a circle? We talked about this in section 2.4. That's where we have x minus h quantity squared, y minus k quantity squared equals r squared. So a nice graph-friendly form. On this rectangle right here, we already said area was base times height. So for that particular rectangle, what would the area be? It would be x times y. We've got a specific name for both the height and the base. Area of this triangle? 1/2 x times y. Okay, it looks like they're at right angles. We'll assume that they are. Okay. Formula for the distance between 2 points. Now don't get confused with this type of distance and distance, rate, and time, the relationship there. Distance between 2 points is that formula where we find the difference in the x's, square that, and all that sort of stuff. So big capital D, and then Makia, what do we write next?
Square root or plus or minus.
No, you're okay. Square root.
So it'd be x1 minus x2
I'll take that. x1 minus x2.
squared plus y1 minus y2 squared.
And does it matter whether we do y1 minus x1 minus x2 or x2 minus x1? Doesn't really make any difference. It's a huge deal in slope and in some other formulas. Not a big deal here. Can somebody tell me why it's not a big deal on this particular formula? Because you're going to square it anyway. All you're doing is you're finding the difference between the two of them. So that's going to be a number. Whether it's positive or negative doesn't matter because you're going to square it in the end anyway. Okay? And what is the distance between 0, 0 and 4, 3? What is it? So we already worked it out here. So I'm going to do 4 minus 0 quantity squared and then 3 minus 0 quantity squared. Again, difference in the x's, difference in the y's. That's going to be 16 plus 9. Square root of 25 is 5. Now look at this next problem. Tylin, you were quick with the last answer. Can you be quick with this one? How do I find the distance between 0, 0 and xy? Close. Okay, so we're thinking ahead here. It's a big square root. It's going to be x minus 0 quantity squared and y minus 0 quantity squared. So that's going to give us x squared plus y squared. Can I just take the square root of both pieces and then add them together? Can I distribute the square root to each one of those terms, find them separately, and then add them together? Nope. That's the answer right there. That's as far as you could go. Okay? All right. Any questions there? Okay, then let's take a look. These ideas, a lot of these are just, now correct me if I'm wrong, but I don't think anything on here should have been at all difficult except for maybe the last problem. And that's just to kind of point out some, kind of clarify some details, some properties of squares and square roots that we want to make sure that we're aware of. These are kind of the building blocks that you already have that will allow us to solve these problems. And every one of these is a story problem. Now, that doesn't mean we need to freak out or anything. It just means we need to be a little bit careful about how we go through and do these. So, problem number 2, and this is directly out of your textbook. It says, let P equal xy. So we've got this point, xy. And it's a point on that curve, y equals x squared minus 8, which is we think about this a piece at a time. It's a parabola, opens up, then moved down 8. So I find that most of the time math makes more sense if we kind of read it slowly. I mean, don't look at this as one gigantic problem, break it down piece by piece. So we've got a point on that curve, we know what that curve is, and it says express the distance from P to the point 0, negative 1 as a function of x. Well, even if I read part A slowly, that still seems kind of difficult. So let's start drawing a picture here. We're going to take this function and we're going to graph that. So that's a parabola that opens up and been moved down 8. So we've got a graph that looks something about like, oops, down 9, yep. So here, 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 looks something about like this. And then if we went over 3, it would be up 9. So it looks something like this. That's what our curve looks like. Now, did it say where xy was on this curve? Could be anywhere, right? So it doesn't matter where we put it. I'm going to put it right here. That's going to be the point x comma y. You with me there? Okay, this is point P, and it says we want to find the distance from that point right there that we just drew to what point? 0, negative 1. Right there. So this is what we want. We want that distance right there. This point is 0, comma, negative 1. I want to find how far it is between the two of those. Now, if I had put it down here, everybody watch. If I had put it down here, it would still be labeled xy because it didn't specify which point it is. If I put it over here, it would still be xy. If I put it down here, it's still xy. You with me there? So can somebody tell me how this problem right here, part A, is related to this one? What's that? You're finding the distance between a known point and an unknown point. And the cool part about this is the only thing that we need to change here is it's not 0, 0 anymore, it's 0, negative 1. So let's follow this same pattern here. Now, this wasn't very difficult, was it? So part A shouldn't be very difficult. Let's write down what we get. So the distance should be equal to, it should be a big square root. It should be the difference between x and 0, x minus 0, quantity squared, plus y minus what? Remember, the minus is part of the formula. The number that's in place of the y, the coordinate there for y happens to be negative 1. So that's going to be a y plus 1. So here's what I get. I get a square root. I get x squared once I simplify this, and I get y plus 1 quantity squared. Everybody good with that? Okay, now, what is the problem with this? Because we're not quite done. It isn't very pretty, okay? Let's read this last little bit right here. As a function of x. How many variables do I have here? I have 2 variables. So I couldn't very well write this as distance as a function of x and then put a y in the formula. So was this difficult getting to here? Not very hard. Does anybody see what we can do now? Well, that would still have 2 variables because it would have a d squared, well, 3 variables if you wanted to think of it that way. It'd still have 2 variables over here. Plug in something. Very good. What are we going to plug in?
0.
That would be nice if we could do that. What does y equal?
5.
Nope. Doesn't equal 5, not all the time. What's that? There we go. It's right here.
Oh, you're so clever.
That's what y equals. So if I come here and I put this stuff in place of that, here's what I get. I get x squared, then I get x squared minus 8 plus 1 quantity squared. And then let's go through and simplify. So this is going to be d of x equals, this is x squared, this is going to be x squared, that's a minus 7, isn't it? Quantity squared. Now, that's still not pretty, so let's clean it up just a little bit. And this is why those skills that you learned in 1010 are so important, because I need to go through and I need to simplify this expression. I don't want to leave it that way. So let's write it like this. This is going to be x squared. If I square that binomial, I'm going to get x to the 4th minus 14x squared and then plus 49. You with me? Right? Then I can combine these together, so I'm going to get d of x equals, this is going to be x to the 4th. I'll put that one first, write it in descending order. Then this is going to be minus 13x squared and then plus 49. That's the answer.
This is how our homework problems are
Let's see you roll your eyes again. That was pretty good.
going to be. I will.
Any questions? Okay. Have we answered that question? Express the distance d from the point P to that point 0, negative 1 as a function of x. Do I have it written as a function of x? Yes, we do. Okay? Now, here's the interesting thing. They actually ask us to go through here and they say, what is the distance if x is equal to 0? So if I'm on this curve and I let x equal to 0, it's not over here anymore where I've drawn it. It would actually be, well, when x is 0, where is it? It's right down here. Now, my question for you is, do I need an equation to tell me how far it is from here to here? No. This is negative 1. This is negative 8. How far is it? 7. It's only 7. Should be positive 7, right? Look at my function. If I plug a 0 in, if I find the distance when x is 0, I get 0, 0, and the only number there is a 49. Does it work?
Yes.
It works for that particular one, okay? And then it says, what is d if x is equal to negative 1? So I found that d of 0 is square root of 49, which is 7. So there's the answer there. For part C, so that would be B. So for part C, we're going to find d of negative 1. So then I have, let's see, negative 1 to the 4th. 1. Negative 1 squared. 1 times negative 13. Negative 13 plus 49. So this is going to be the square root of 37, right? Is that 36? 36. No, it's not. No, it's 37. It's 37 because you'd have 1 plus 49. That'd be 50. Subtract 13. That'd be 37. Is that bigger or smaller? Bigger or smaller than 7? Smaller. Okay, watch. If I put this point at negative 1, I'm finding that distance right there. It should be shorter than 7 because 7 was from here to here. We're looking for a distance that would be smaller.
It's like 6.12.
Seriously. Okay, that's what I was going to say. Yeah.
So, but also just, I think probably when we go to more complex graphs, we can't do this, but going on this graph, couldn't we just plug in a point? Because we already know what.
Sure you could.
Yeah, like
But
negative
they didn't
1.
ask you to do that. And once you have this equation, why do these two by hand by figuring out what the 2 points are and then using the distance formula this time? And what if they said find the distance between, what if they gave us 8 problems like this? Do we want to go through and find all 8 points and then use the distance formula 8 times? Or do you want to use the distance formula once and then just plug in x? Does that make sense? This is much, much better. Okay, I realize this is brain stretching. You don't think like this all the time. Okay, but in the long run, if you want to do higher mathematics, if you want to be an engineer, if you want to get into med school, if you want to go to law school, different things like that, this is the type of brain they want. People that can figure out this stuff. Not impossible, it just takes some practice. Read it slow, think about what's going on, draw some pictures, solve the problems. Any questions? Okay, then it says use a graphing utility. Now, you don't get to use these on a test, but we're going to throw this in the calculator really quickly. And it says, when is it at the minimum? So I'm going to do this one real quickly. It's a big square root, and then it's going to be x to the fourth power, and then it was minus 13x squared, and then plus 49. I'll close the parentheses, and then I'm going to go back to the home screen, clear everything off. I'm going to check what the window is. This is a pretty small window. So I'm going to hit zoom 6. That's the standard window. It goes from -10 to 10. And that's what it looks like. Okay, now,
That's what the graph that we just did looks like?
that's what this one looks like. That's square root. It's okay. Square roots normally don't exist when we plug in negative numbers, right? Can somebody tell me why this exists over here? Why it has values when we plug in negatives?
There's fours and squares.
Yep, because we're going to raise to the fourth. That's going to take anything that's negative and make it positive, and a pretty big positive, by the way. Okay, that's going to make it positive. Then we're going to subtract that, and we get to add 49. Okay, now, we okay with that? It's a good thing the calculator did this graph for you, huh? Good thing this isn't a parent graph that you have to have memorized. My question for you is this. What's the function value right there?
8.
Close.
7.
7. If I hit trace, if you plug in a 0, it should tell us that the answer we got right here. Now, somebody on their calculator, what was it really 6.12?
Well, that's just what my 6.08.
6.08. Watch. I'm going to type in a -1. This is going to jump to that point. The distance is 6.08. So it told us the same thing. Now, why does this look like it's symmetric about the x-axis? Why does this, the y-axis, why does this look like an even function? Yes?
Because if you plug in either -1 or 1, it'll just be squared fourth, raised to the fourth, so it's going to be the same number either way.
Yep.
Same as the gravity.
Very, okay. So because this is symmetric over here, hopefully we're not, yeah, because if we went over on this side, oh, this is freezing up again. That's no good. Okay, are we back? Nope. Must be that program. Let me save that. We'll get out and we'll start up again. Okay, it does have to do with the symmetry. That's basically what it comes down to. Okay, let's take a look at part E. It says for what values of x is d the smallest? And where would that be here? Where is the distance the smallest?
At 0?
At 0, the distance is 7.
Not on that one. I was looking at this.
Be about right there. And again, you could use a calculator to find where that minimum distance is. Okay, it looks like it's about maybe a little bit less than 3. See how we're doing here? Looks like we're back up and running. I would say that these two are about the closest right there. See how that point is a little closer to 3 than it is to 2? That's where the smallest distance would be. And once I move over here, the distances get longer and longer and longer. Does that make sense? Okay, all right, let's take a look at the next one. Now, before we move on, let me point out that a lot of these problems have some very similar concepts. On this one right here, we did this problem right here, but the problem was it had an x and a y in it. And then we said, well, wait a minute, what could we substitute for y? We're going to do something similar on this one and see if you can spot what it is. So on example number 2, it says a rectangle has one corner in quadrant 1 on the graph of 25 minus x squared. By the way, we know what shape that is. Parabola that's been moved up 25 and opens upside down. That's why we've got this shape right here. Another at the origin, and a third on the positive y-axis, and a fourth on the positive x-axis. They've done us the favor of drawing a picture of what this looks like. It says express the area of the rectangle as a function of x. So if this point right here is xy, and this is a rectangle, it's x from here to here. Now I realize they showed that it's 3 right here, but we could have this rectangle like this or like this. All that we're going to do is we're going to vary where this point is on that curve. That's what's going to determine the shape of the rectangle. Is everybody with me there? Okay. So this is an x coordinate. That's how wide this is. How tall is it? It's y. So if I have a rectangle that's x wide and y tall, what's the area of that rectangle? X times y, right? What don't we like about this? Why is this not a plain old function of x? Two variables. So can I substitute for one of those? I'm going to take that and I'm going to put it right there. So here we go. A of x equals x times 25 minus x squared. Now, is that a function of x? You bet. What's that? We could distribute through if you wanted to. Really wouldn't matter. Okay. What is the domain of A? What numbers can you plug in for A?
Any number?
It does look like any number, doesn't it? If we just looked at this, it would be any number. But remember, this has to represent the area of this rectangle right here. So what's the smallest x can be? 0, okay? Now, if it actually was 0, how wide would the rectangle be? It would be 0. It would look something like this. It wouldn't have any width. It would just go right up to here and come straight back down. So you're right. So it doesn't really include 0, does it? What's the widest it can be? How big can x be?
3?
Well, 3 would stop right here. Couldn't I make it like this?
Oh, yeah.
Or couldn't I, as Tylin said, couldn't I draw a line straight over here? Go that far, right to where that hits the x-axis? So how far could I go?
5.
I could go to 5. That make sense? That would keep this rectangle in the first quadrant meeting the criteria that was described up here. Good? Yeah.
Why don't we put 5 in brackets?
Because if it was actually 5, it wouldn't have any area at all. It wouldn't have a height. It would be a line. It would go straight out here, and because this other point is on this curve, if we went out to 5, it would have no height at all. Just like if we went to 0, we'd have height, but we wouldn't have any width. Does that work?
Yeah.
Okay, and it also wouldn't be in the first quadrant anymore.
Okay.
Good? Okay. Graph that. Let's have a calculator graph that. This textbook, in my opinion, wasn't designed to be taught without a graphing calculator. So we're going to type in x and then 25 minus x squared. And then a good place to start is just the standard window. So I'd hit zoom 6. We were already there, but there you go. Can't see the whole thing. Are we interested in all this stuff over here and all this stuff down here?
No.
We're not. So let's go to the window and let's change this. Let's go from -1 to 6. Now, why would I go from -1 to 6?
Because it can't go past 5 or 0.
Yeah, and then these aren't the very edges of the window. Okay, I can see what's happening a little bit outside that and kind of reason my way through that. Am I interested in, now remember, this is A, it represents area. Am I interested in negative areas? Nope, okay. I'm going to use like a -2 here, and let's see how high this goes, see what our area could be. Let's. Okay, I was going to put 20, but now I'm going to go 50, and I'm going to put a tick mark every 5.
Look, that was perfect.
That was perfect, what I was trying to demonstrate. If we had done 20, it wouldn't have been high enough, so we would have had to go back and change that. There's nothing wrong with taking a bad guess. Okay, but then it says we've got a graph for what value of x is A the largest. We'd want to find that point right there. Now, it looks like it's about 3, doesn't it? Yeah. At 3, which would mean we're about that triangle, or that rectangle right there. Again, you don't have the advantage of using your calculator for these, so I'm just going to quickly run through and find this. We'll have it find the maximum, and it occurs at 2.88, something you would never guess and wouldn't be able to find, generally speaking, without a calculator. Okay? All right, any questions?
Are we on homework, on our homework questions that we are gonna have to use a calculator?
No, I believe so.
So do we ignore them or do we?
Um,
Don't know how you
who has a graphing calculator? Okay. If you don't have one, borrow one. They have some in the office you can check out too. Yeah.
So how do we record C and D on our homework, or do we just do it and say we did it?
Okay. I mean, it might be good if you sketched a picture or something like that of what the graph looked like.
So it doesn't have to be accurate. It
Mm-mm.
could be like, this is what it
Nope.
looked like.
No, these would be very hard to do accurately by hand. I mean, you kind of got to rely on a calculator or a computer. Any questions? If you don't have a calculator, you can also go online. There are lots of places where you can find free graphing calculators. Okay. All right, let's take a look at the next one. And again, we've covered the basic ideas, but let's take a look at this one right here and see if we can solve this one. It says a right triangle has one vertex on the graph of y equals x cubed. X is greater than 0, so that means we're on this side over here. We're in quadrant 1. Another at the origin, and a third on the positive y-axis, as shown in the figure. So here's the picture we're dealing with. Express the area of the triangle as a function of x. Now, can somebody tell me something that's nice about this? Okay, Tylynn's being very negative. Ignore her. It's a right triangle. We like that. How about compared to the number of questions they asked on these other guys?
Oh.
We only have one thing. Come up with an equation in terms of x. Come up with a function of x, a of x. Now, if this is a right triangle, all I need is the base and the height. My question for you is, if this is 0, 0, and this is 0, y, how far is it from here to here? Again, Tylynn, quick with the answers. This? X. Have we seen something like this before?
Yeah.
Wasn't this in the starter question? How do you find the area of a triangle like this? 1/2 x times y. Marissa, what's the problem with this? Two variables. Do I have anything I could substitute? In place of y, I can put a cube. So now this is truly a function of x, so I'm going to put a of x, 1/2 x times x cubed, and I'm going to write this as simply as I can. A of x equals 1/2 x to the 4th, and that's it. Now, earlier, Zach said, well, why wouldn't you just figure out where your point is and then figure out the distance between those 2 points? Or the equivalent on this problem would be, why don't you just plug in a 7, figure out what 7 cubed is, and then figure out how wide it is and how tall it is, and then take 1/2 base times height. Well, you could do that, and then you're stuck with all numbers, and maybe that seems a little bit easier with numbers, but what's the advantage of having this little formula? Plug in any number you want. So I could say, hey, what if this is at 7, what would that be? 343? Plug in a 7, this spits out the answer. What if this is at 0.2? Plug in a 0.2, that spits out the area of this tiny little triangle right here. Okay? So those formulas are really powerful. If you can write an equation that represents what you're after, you've eliminated a bunch of work, and then it's just plugging in numbers, and a calculator can do that. A very simple calculator can do that. Any questions? Sure? Okay, let's keep going. So that's kind of the flavor of most of these problems. You just have to stop and think about, okay, how can I take what they've given me, draw a picture, look at a graph, think of functions I already know, area formulas, stuff like that. How can I do that? And then come up with an equation for whatever they're asking me to. So a wire of length x is bent into the shape of a circle. Express the circumference of the circle as a function of x. So I took a wire that's x units long, and I bent it into a circle. Because they said to. How far is it around the circle? X. So to go all the way around the circle, it's going to take x units to go all the way around. Now, do you have a formula for the distance around a circle? Okay, 2 pi r. Now, what did we just get done saying the circumference was? X. So x must be 2 pi r. Now, Express the circumference of the circle as a function of x. What's that? There's an r there. But we need an x. So what is r in terms of x? Could we solve this like we did the other ones to figure out what r is so I can write it in terms of x? Take a look at this guy right here. What is it? It is x over 2 pi. This is only slightly more complicated than the previous one because on this one it had exactly what we needed to plug in there. This, it doesn't. We're going to take this and we're going to divide both sides by 2 pi. So I get r equals x over 2 pi. Now, if I take this, and I plug it in here, then I get c equals 2 pi x over 2 pi. So what's the circumference? Whoa, that's weird. The circumference of x is x. Couldn't we have figured that out right here? Sure we could have. Okay? Express the area of the circle as a function of x. Is this going to come in handy now? Is this a relationship between what the radius is?
Yeah, it's just gonna be radius squared equals x over pi.
Okay, area is pi times r squared. What's wrong with this right here?
The pi needs to be with the x.
Okay, the equation needs to be in terms of x. What's it in terms of right now? It's in terms of r. Do we know what r is? It's right here, isn't it? So this would be pi times x over 2 pi, quantity squared. So now I've got the area as a function of x. Let's see what I get here. I get pi x squared. This would be 4 pi squared, right? Can I do anything to clean that up a little bit? Cancel the pi, cancel that pi. So the area as a function of x is, what goes on the top? X squared, and what goes on the bottom? 4 pi. Okay, so there's B. I'll make that look a little bit better. Here's A. Any questions? Sure? Okay. All right, we got 2 more problems. Any questions? Okay. Would you read 18? Think about it for just a second. Okay, any ideas on what we'd need to use here? Okay, we got to use distance equals rate times time somewhere in here. Anything else? Maybe organize it into a table. Draw it. Who said triangle? Okay, we're going to draw a triangle here. So here's the deal. We've got this car speeding out of town like this. And it says, let's see, one is heading south at 30 miles per hour. The other one is heading west at 40 miles per hour. So this is 40 miles per hour right here. That's its rate. And this one is heading south at 30 miles per hour. And what we want is this. We want to know what the distance is between those. That's what we want right there. What type of triangle is this?
Right.
It's a right triangle. And we know something about the legs. Okay, now there are a couple different ways to go through and solve this. Does anybody know what the answer is off the top of their head? Just plain old 50? Yeah. We are going to use the Pythagorean theorem. Okay. It is possible on this particular problem to solve it without using, well, just thinking about the Pythagorean theorem, okay, or knowing the relationship on this particular triangle. Okay, here's what we're really after. Okay, I'm going to take however long this is and however long this is, square each one of them separately, then add them together, then take the square root, and that will be how far it is from here to here. But this is always changing. This is getting bigger. This distance is 40 times however much time I give it. So if I give it an hour, it's 40 miles. If I give it 2 hours, it would be 80 miles. If I give it a half hour, it's only 20 miles. So it's changing. So this side right here, I'd represent with 40t. This side over here, how would I represent that? This would be 30t. So this is what I've got. I've got a triangle where this is 40t and this is 30t. And what I don't know is what's this distance right here. It does change, but we can represent it as a function of time. So if this is 40t and this is 30t, what equation relates the three sides of a right triangle? So d squared should be 40t squared plus 30t squared. If I wanted to know what d was, I'd do this, square root of all that. But this is going to be 1600t squared. This is going to be 900t squared. What do I get? 2500t squared. And what's nice about 2500t squared in this particular problem? It's a perfect square. It's a perfect square of 50t. So the distance is 50t. Now, remember it said express the distance as a function of time. So the distance as a function of time is going to be 50t. Now, because of this particular problem and because this is a 3, 4, 5 triangle and it does work out to be a perfect square, you could have figured out there were a couple people that knew it was 50t before we even did that. Okay? That's great on this problem, but if this number were 22, 2230 is not a Pythagorean triple. They're not part of a Pythagorean triple, so you'd have to rely on this method right here. It may end up with you with some stuff stuck underneath the radical. That's okay. All right, any questions? Okay, last problem then. Circle is centered at the origin with a radius of 5 inches. Remember what I said? Story problems usually make more sense if you read them slow. Circle centered at the origin with a radius of 5. In Math 1010 and a week or two ago, we actually talked about a circle centered at the origin with a radius of 5. You should know how to write an equation for that.
I do.
We're proud. Okay, next part. A rectangle has 2 vertices on the circle, one in quadrant 1 and one in quadrant 2. The other 2 vertices are on the x-axis. Express the area of the rectangle as a function of x. And then it has a hint. Draw a picture. Find an equation for the top half of the circle. Use the examples in this section as a reference. So let's draw a picture. Circle centered at the origin. And it says we're only going to use the top half because our rectangle is here. You with me? Find the equation of the top half of the circle. Now, if I say a circle centered at the origin with a radius of 5, who can tell me what the equation of a circle centered at the origin with a radius of 5 is? Is that what you were going to say? That's fine. X squared plus y squared equals 25. Now, that's the whole circle, top and bottom included. Remember, this wouldn't be a function. Okay? How do I just get the top half of the circle? What's that? Take the positive square root. Write this as if we were doing y equals. So I'm going to take this, I'm going to move it to the other side. So this is going to be y equals 25 minus x squared. Whoops, y squared equals that. And then if I want the top half of the circle, if I want to solve for what y is, I get y equals the square root of 25 minus x squared. You with me there? That's going to be the top half of the circle. It's the same equation. All I did was solve it for y, and when I took the positive square root, that's going to give me all positive y coordinates. That's got to be the top half of the circle. Okay? Okay, now, how far is it from here to wherever this point is right here?
5?
Well, as all the way over here, it would be 5. What about right there? How could we represent that? Do you know where it is?
X.
This is x. How far is it over here? Also x. How do we represent heights on the xy plane? That's going to be y. So I'm going to take this and I'm going to draw the box over here. How far is it from end to end? In other words, what's the base?
Squared.
There are 2 x's. Okay. How tall is it? How would you write the area of that box?
2x.
Okay, now since Marissa's answered this question every single time, I'm going to count on her to get this right. What's wrong with this? There are 2 variables. There's an x and a y. Justin, what do?
We can get y by itself, or we can put it into the equation.
We can take this right here that says what y is in terms of x, and I'm going to take this and I'm going to plug it in right there. And that's going to give me, now I can write it as a of x because it truly is a function of x, 2x, and what did we put in place of y?
Square root of.
Now, does it say graph this? No, luckily just come up with that. Yeah,
Is 1.96 squared perfect square?
no, it's a difference of squares. And remember, you can't take, so it looks like we ought to be able to take the square root of 25, the square root of x, and then subtract them. Remember, you can't distribute a square root through to different terms, okay? It only works when we've got factors, pairs of factors. Does that make sense? Okay. Good? Okay, we've got pseudo review tomorrow. We've got a review Friday, more review on Monday. Better make sure that you're ready to take the test. Absolutely, hold on, don't go anywhere. Absolutely, there will be questions like this on the test. So you can't just blow off story problems and say, oh, I'm pretty good at everything else, this will be okay. Now, let me just point this out. There will be days, I could have taken much longer going through this. I wanted to make sure I got through all the problems. There will be days where I will talk for 50 minutes, okay? From 1:30 until 2:20 nonstop. That's how long it takes to cover the material. So if today we had time to go over one question and we went over it very quickly, we didn't go over one of the other questions that was asked. The reason you need to ask questions by coming to office hours, finding me, make an appointment, whatever it happens to be, get here early, come in and see me at lunch, whatever it happens to be, how would you know the difference between a day where we have 2 minutes to talk about problems, 5 minutes at the most to talk about problems, or 0? You don't. What if you show up and say, I'll ask about it in class, and we don't have any time to take questions in class? That's right. And what if I called on for the assignment today and you didn't have it done? There you go. Okay? That's why you need to come to office hours to make sure your questions are in. Okay? All right. Have a great day. See you.